My name is Fedor. I'm a student from Moscow, and I've been doing some competitive programming lately. And this talk will be about competitive programming and what parts of GNU C++ library we use to save several precious minutes. But first, a quick poll. How many of you have ever done competitive programming in forms of ACM ICPC contests, school Olympiads, or Google interviews? Oh, that's better. OK. So, well, competitive programming usually happens during a contest. And in the beginning of a contest, you get a problem set and just 2 or 5 hours to solve it. So to solve it, you have to come up with the right solution and then to implement it so that it works at least algorithmically fast and correctly. And if your solution requires some fancy algorithm or data structure, then, well, if it is not there in the standard library, then you're probably going to implement it yourself by hand. So, well, we obviously use standard library quite extensively, like all these optimal algorithms for sorting, binary search, next permutation, and so on. But you may not know that there is one header in GNU C++ library that includes all the standard headers, so that you don't need to spend time on beating all these headers into the keyboard. So next up, there are several useful built-in functions for bitwise operations. You can see that there are even const export, which is cool. You can use them for getting the number of set bits and counting the leading and trailing zeros, which are in turn useful for discrete logarithms or something like that. Next up is another extension, which is power. Sometimes something is similar to exponentiation, but not exactly, like matrix exponentiation or operations modulo some number. So that's that power does not do what we expect, because it works only on real numbers. But this still can be done fast in just logarithmic time. And to do that, you just need to define what will be the multiplication and what will be the identity element for this multiplication. So that, well, if you exponentiate something to the 0th power, then it will be the identity element. So this code checks that the Fermat-Little theorem holds for some number and some large prime number. To do that, it exponentiates the number to the billionth power in just 50 multiplications. And the last one, there are many useful data structures invented, and only a few of them in the standard library. So GNU library provides policy-based data structures that implement several other data structures in an extensible way. The most important example is that, for example, with standard set, we don't have a method for getting the element from a structured sequence just by its position. We need to know its value to get the iterator to it. We don't have this method because it requires to maintain some additional memory in each tree node. But with PBDS, we can do that. Because PBDS provides a special implementation of tree that accepts special policies for extension. And also PBDS implements a policy that does exactly what we need and adds additional methods. So here's how you would declare it. The first 3 template parameters are exactly the same as for stud map. The 4th parameter is about red-black tree, and the last parameter is the extension that enables order statistics. And here's how you would use it. It's just a normal set, but with additional methods for access by position. Now some downsides. C++ is very popular in competitive programming, but it lacks big integers. So sometimes we just have to switch to Python or Java instead of, again, spending 10 or 20 minutes just for some stupid implementation. And that's it. Thanks for having me again. There are several more examples on my GitHub, and I advise to take a look at GNU++ library manual. There are some more examples there. Thanks.